So in this lesson, we're going to continue to talk about the Math IA rubric. We're now in the second part out of 5. The second part, Criterion B, is called Mathematical Communication. So the first thing to know is that mathematical communication is the second out of the 5 grading criteria, and it's worth 4 out of the total of 20 points for the Math IA. As usual, 0 points means, hey, you didn't do any of the things down below. For 1 point, it says the exploration contains some relevant mathematical communication which is partially appropriate. I'm going to be dissecting these things and talking about them more later. I just wanted to sort of share some of the wording with you now. For 2 points, the exploration contains some relevant appropriate mathematical communication. So we're going to keep seeing these words relevant and appropriate. And really that's part of what this video is going to be about, like knowing what the difference is. For 3 points, the math communication is relevant, appropriate, and is mostly consistent. So now we're bringing this word consistent. And then for 4 points, the top of the rubric for this, the math communication is relevant, appropriate, and consistent throughout. I definitely find that this criterion is a little harder to understand than A is, but IB does give us some good guidance on that. So that's what we're going to look at next. Before I get into IB's official guidance, though, I did want to share with you sort of my struggle with the concepts of relevant and appropriate on this rubric. So this past year, in 2020, 2021, when I was training to be an IB examiner, I had the hardest time understanding what the difference was between relevant and appropriate on this rubric. Like I literally spent hours trying to figure out what IB wanted the difference to be. I feel like the words relevant and appropriate are close to one another. And you know, when you read the assessment criteria, you get the sense that being appropriate is better than just being relevant. And after talking to some of the other official IB examiners, I finally started to understand that your communication can be relevant, but not appropriate. And this is not good, by the way. This is what we want to avoid. So your communication can be relevant, but not appropriate by communicating about the math that you're doing. That makes it relevant, but not using standard notation, standard symbols, standard vocabulary, which would make it not appropriate. So if it's relevant, it means, yeah, it's about the math that you're trying to do. It's relevant, but not appropriate, meaning that you're not using the right words, not using the right terms, not using the right symbols, things like that. And the IB guides literally state this. They say examples of a level 1, which is sort of like the lowest other than the 0, would mean you have graphs, but they're not labeled, and that you consistently use computer notation, which means not exponents, but like carets or, things like that, with no other correct forms of mathematical communication. This would mean that you would have relevant mathematics, graphs that don't have labels, notation, but it's computer notation and not math notation. So it means that work would not be appropriate. So I hope that makes sense, like that difference between relevant and appropriate. So now the key ideas in mathematical communication. When we look at the guides from the IB, both for ANA and for ANI, the guides say that it sort of assesses these kind of 4 different things. 1, have you used, and you're going to see the word appropriate everywhere. So remember that appropriate means that you're using sort of the proper terms, the proper notation, the proper language. So first of all, did you use appropriate mathematical language? So were your notations, were you using a proper square root symbol? Were you using proper exponents? If you're doing integration, were you using an integral symbol? Were you putting these things in the right places? And that does include things like making sure that those symbols are lined up properly. That does require either that you handwrite your IA, which you're allowed to do, but pretty much everybody types them, or it means that you learn to use Microsoft Word, which, remember, is better to use than Google Docs for math typing, and then using appropriate symbols, and then using appropriate terminology. The guide does say that calculator or computer notation, what do we mean by that? That means like using a caret for exponents, or, saying this thing raised to the 1/2 power, like what you'd have to type into, I know Desmos auto formats a lot of things, but some computer programs like Excel, Excel's a good example. Excel isn't going to format those things nicely. So if you use that to make a chart or a table, that's okay, but it's only okay if that's the only way the software works. If you're typing something in and you're typing it, you should be able to have the appropriate notations. So like I said, in all other cases, you should use appropriate mathematical notation in your work. Sorry, I took a little while on that one, but that difference between if you're using a piece of software and it automatically uses the wrong notation, that's kind of okay. But anything that you have control over, you need to use the appropriate notation. You need to define key terms and variables whenever they're necessary. So the thing about key terms, anytime you're using, like particularly if you're doing an area of math that's not covered in the IB math class, make sure you define what those terms mean. That doesn't mean that you get out like a Webster's dictionary. It means you get like a math book, you get a math textbook. You get something that's going to give you a good mathematical definition of the terms you're working with. You also need to define your variables anytime you use them. And it's really, really important that we define variables precisely. Please don't say things like d equals distance or let d be distance. It's like, distance what? Like what distance are we talking about here? Your definitions should generally be complete sentences. So saying something like let d be the horizontal distance traveled by the object during the time period is way, way, way better than saying d equals distance. You'll notice I even said horizontal distance. Like, imagine that you were like throwing a ball or something. If somebody said d equals distance, do you mean the distance it traveled vertically, the distance it traveled horizontally? Maybe the distance that it traveled on a path. Like, those are all distances. You want to make sure that you're precise about what you mean and what you're talking about. Continuing, this again comes from the guides, and there's a lot here. Sorry, this didn't come up in multiple bubbles here. Another thing that the guides say is that this criterion checks that you used multiple forms of mathematical representation. And what that means is, it means that math communication, math representation, is more than just formulas. I know that when you guys do like your math homework on things, you'll mostly use formulas, but keep in mind, sometimes you'll draw a diagram. If it's appropriate in your, there it is again, appropriate, if it's appropriate in your exploration to include diagrams, or tables, or charts, or graphs, or mathematical models, any of those things, when they're appropriate, you should use those forms of mathematical representation. If you including a chart makes it easier and better to communicate the math that you're doing, use a chart. If the thing that you're doing is hard to understand without a diagram, put in a diagram. I will mention, by the way, that it's totally acceptable if you just can't find a way to generate a diagram well on your computer. It's totally fine to draw that on paper, take a nice picture of it, and then put that into your document. Totally acceptable to that. They're not gonna take points away because you didn't do a computer generated version of that. They look nice when you can do computer generated ones, but if you can't, fine. Do a nice drawing by hand, paste it in. With all of that in mind, please remember appropriateness. Formulas need to have variables defined. Diagrams need to have labels and descriptions. You can't just say, oh, here's a diagram that will help make sense of it, and then don't describe it. You need to walk your reader through what you're trying to show them. Your tables need to have clear headings and explanations. Your graphs need to have labeled axes. I guess part of what I'm saying here is there's pretty much nothing in math that you can just plop into a paper and be like, yay, it's better. You need to communicate differently for each type of mathematical representation that you do. Your graphs need labeled axes. They need a clear scale, so the scale numbers on the side need to be large enough to read, and you need to explain them. If you're doing a mathematical model, like you're trying to come up with a formula that's going to work for something, you'll need to define variables. And you'll need to describe what you do, to help the reader understand how to use your model. As we continue on, the IB guide states that level 4 can be achieved by using only one form of mathematical representation. So up here we said, oh, make sure you use multiple forms. You don't have to. You can totally get the highest level, level 4, by using only one form of mathematical representation, as long as this is appropriate to the topic being explored. So if you are trying to prove some mathematical relationship, and all you really need to use is a ton of formulas and equations, and it doesn't make sense to use diagrams, tables, charts, graphs, models, if it makes sense to only use one, that's okay. Please don't force multiple representations if it isn't appropriate. So don't sit there going like, man, my eye is perfect, but all I did was graphs. How do I figure out how to like squeeze a formula in here or an equation so it look like I use more things? Don't do that. If your paper is good and solid and communicates well, even with only one thing, cool, leave it with one. The guide also states that for level 4, for the highest level, minor errors that don't get in the way of clear communication should not be penalized. So IB does not expect these things to be perfect. It's okay to have errors here and there, as long as they don't hinder communication. Remember that for level 4, it said that your notation had to be relevant, appropriate, and consistent throughout. So if there's like one spot where you have a little slip up in notation, or one spot where you don't define a variable quite well enough, it's going to be okay. But you should do the best that you can. We continue this idea of key ideas in mathematical communication one more time. So the last thing that the guide says is that you should use a deductive method and set out your proofs logically when they're appropriate. So I read this to mean that you should use a deductive method at all times. And the deductive reasoning basically means that you should draw conclusions from general statements that you've already shown. So, you wouldn't have this exact sentence, but the idea is, let's say you just did something. Because we just showed XYZ in the previous section, we now know deductive reasoning, ABC. And so our next step is to determine if DEF. You see how there's sort of these like logical steps. There's the deductive method that's going through. You should also, if you're doing a proof, make sure that you really set your proofs out logically. So these are kind of the main ideas in mathematical communication on the rubric. I think that I had more on this. Yeah, okay. So just as a quick recap of the achievement levels. So now that you... Sorry, I'm trying to move my face out of the way here. Oh, here we go. It can be hard to keep track of all of this information at the same time. So I wanted to redisplay the achievement levels. Now that we understand that there's 4 things. There's the red part using appropriate language. There's the blue part defining key variables and terms. There's the purple part using multiple forms of representation. And the green part using a deductive method. Oh, I paused on the screen down here. We will bring me back here, but not like that. Okay, there we go. So the quick recap of these 4 levels. Oh man, I'm gonna let me disappear from there. For 0 points, the exploration does not reach into the standards below. For 1 point, it has some relevant communication, and it's only partially appropriate. So you used math that was relevant, but you didn't. It was mostly not appropriate notation, language, definitions, shapes, forms of things. For 2 points, there is some relevant and appropriate communication. So some communication that's both relevant and appropriate. For 3 points, you've got relevant, appropriate work, and it's mostly consistent. Like, there's only a few places where you've got, things being a little off. And for 4 points, that mathematical communication is relevant and appropriate, and it's consistent throughout the exploration. So sorry I'm not here on the screen to wave at you this time, but I hope that made sense. I hope that helped you to make sense of Criterion B. If you've got questions about that, please make sure that you ask about them. This is a hard one to understand, and so I want to make sure I'm doing all I can to help you make sense of it. So, like I said, if you've got any questions, let me know. Otherwise, best of luck as you work through your work and continue to develop as mathematical writers.